In lesson 11, we're going to compare ratios using ratio tables. Our first example asks us to create 4 equivalent ratios, 2 by scaling up and 2 by scaling down, using the ratio 30 to 80. Before I was able to create my ratio table, I needed to determine what the value was of that ratio. So I took 30 to 80 and I turned it into a fraction, 30 over 80, and then I found that their greatest common factor was 10. So I took 30 divided by 10, and it gave me 3. 80 divided by 10 gave me 8. Therefore, my value was 3/8. With 3/8, I understood that with my first part of my ratio, I needed to count by 3s. And for the second part of my ratio, I needed to count by 8s. Now, it asked me to scale up by 2 and to scale down by 2. And so scaling down, I'm going to have to subtract, because when I scale up, I add. So we're doing the opposite. 30 minus 3 gave me 27. 27 minus 3 gave me 24. Over here, I had 80 minus 8 gave me 72. 72 minus 8 gave me 64. And now we're going to scale up, which is what we're used to. 80 plus 8 gave me 88. 88 plus 8 gave me 96. And 30 plus 3 gave me 33. And 33 plus 3 gave me 36. And so I filled in my ratio table using the value. Now what we're going to see is that once we find unit rate, we're actually able to increase using the unit rate or the value. It's only a unit rate if the value is able to show us per one of the parts of our ratio. So down below, we are given a ratio table, and it's hours of pizza sold, or hours to the number of pizzas sold. As we see here, we have 4 separate ratios on the table, and I take the smallest one simply because it's easiest for me to use smaller numbers to find my value. You could pick the biggest one because with ratios, as long as they're equivalent, the values would be the same no matter which one you chose. So I took 2/16, 2 over 16. I went ahead and labeled the top hours and the bottom pizzas, so I understood that this was 2 hours over 16 pizzas. The greatest common factor they share is 2. 2 divided by 2 gave me 1. 16 divided by 2 gave me 8. Now, the hours carries across. So this is actually 1 hour to 8 pizzas. So what this tells me is in 1 hour, they can sell 8 pizzas. With that being said, I'm able to actually write the ratio that is defining this ratio table, which is 1 to 8 hours to the number of pizzas sold. So it takes 1 hour to sell 8 pizzas, a ratio of 1 to 8 hours to the number of pizzas sold. Exercise 1 now asks us to go a little bit further by comparing the rates of texting for each person in the ratio tables. Now, just like above, what you're going to do is you're going to find the value for each table. Now, something to keep in mind whenever we're working in rate. Always divide by time, and your answers will always be per one of the time. So either per minute, per hour, per second. Every time it's per one, and you always divide by time to determine the rate. So down here, we have words per minute for Michaela. They tell us in 3 minutes she does 150 words, 5 minutes 250 words, 7 minutes 350 words, and in 9 minutes she can do 450 words. Again, you could pick any of these to find the value of. I chose 3 to 15 or 3 to 150 because it's the smallest numbers. So I take 150 divided by 3, again, always dividing by the time, so that's 150 words divided by 3 minutes, and I got 50. So what that means is that she can type 50 words per 1 minute because I took 3 divided by 3 and 150 divided by 3, which gave us the 50. I showed you the long division way of doing this. The next two I'm going to show you as fractions and the way that we normally see value. So for Jenna, she was able to type 90 words in 2 minutes, and then 180 words in 4 minutes, 270 in 6 minutes, 360 in 8. Again, using the smallest numbers, I'd put 90 over 2 for the value. 90 and 2's greatest common factor is 2, so 90 divided by 2 gave me 45. 2 divided by 2 gave me 1. 90 stood for the words, 2 stood for minutes. So my numerator again would be the words, the denominator would be the minutes, which means she was able to text or type 45 words per 1 minute or 45 words per minute. And lastly, we have Maria. And Maria was able to type 120 words in 3 minutes, 240 words in 6 minutes, 360 words in 9 minutes, 480 words in 12 minutes. I went ahead and used the smallest numbers to find the value. That's 120 words per 3 minutes, so that's 120 over 3. I wrote the words in minutes, so I'd remember it's 100. The numerator is for words, the denominator is for minutes. Their greatest common factor was 3. 120 divided by 3 gave me 40. 3 divided by 3 gave me 1, and that would be 40 words in 1 minute, which means my rate was 40 words per 1 minute. All of these are rates following the definition because it was per one of the amounts, and in this case, it was our time. In answering that question, they just want us to compare them. So, in looking at it, who is typing the fastest? A lot of times people want to pick Maria because the number's smallest. But the faster you're typing, the more words you're typing. And so Michaela is actually our fastest texter or typer because she is typing more words in a minute than anybody else. And these are actually in order from the fastest to the slowest. Going to the next page, they ask us to complete the table showing that Max has a texting rate of 55 words per minute. And even though the 1 isn't here, it's still a 1 because a minute is 1 minute. So I started out with my first one, 1 minute, 55 words, multiplied both by 2, got a 2 and 110, added 1 here, or multiplied by 3, took 55 times 3, got 165, and then 1 times 4 gave me 4. 55 times 4 gave me 220. If you want that written in, you're more than welcome to write it in. I'll go ahead and do it just in case you've decided that's something that you would like to see. So we have a 1 times 2 and a 55 times 2. And then a 1 times 3 and a 55 times 3. And then lastly, a times 4 to give us our last part of our ratio table. And Max is actually faster than anyone over here because the quickest one from next would be Michaela, which was only 50 words a minute. So he's able to actually type 5 more words or text 5 more words per minute than Michaela. Our next exercise is making juice. They want us to compare juice to water. All juice is made up of water and juice concentrate. And so the more juice concentrate there is, the stronger the juice taste is. If any of you have siblings, the younger they are, a lot of times they're going to mix in water and juice so that the juice is not as strong for your sibling. Because the younger you are, the harder it is on your stomach for you to taste juice. And so this is kind of looking at the stronger juice flavor there is. So we have, it actually asks us to find whose juice would taste the strongest. And like I said, the more juice concentrate is in there, the stronger your taste will be. So we have 3 tables here. You have Laredo, Franca's, and Milton's. You see that they tell us the amount of water, the amount of juice, and then the total juice there would be for each one. Now, if you look, I've actually highlighted a couple things in there that show you the ones that have a shared number. If you get in a situation where you can't figure out how to find the rate, there are other ways that you could solve it. And for this one, what I looked at was to figure out which one would have the strongest taste and then compare it to the other one. So if you look right here, it's a total of 30 and a total of 30. which means you could compare these ratios to each other to figure out which one put more juice in it. And you see that Franca put 25 parts juice and Milton only had 24 parts juice for the same amount of juice, which was 30. And so Franca is stronger than Milton because there's more juice in hers than Milton's. You also could look at Laredo and Milton. Laredo and Milton also have one that is the same, and you have one that has, I'm sorry, I spoke incorrectly. Since there's more water in Franca's, hers will not be as strong as Milton's because she put 25 parts of water with 24 parts of water for Milton. The more water, the weaker the taste is. Or you could look at the juice, and the juice is 5 parts, and this one, the juice is 6 parts. The more juice, the stronger it is. Now you can compare Laredo and Milton. Laredo and Milton, since we know that Milton's stronger than Franca, we're going to see, all right, is Milton stronger than Laredo, or is Laredo stronger than Milton? The total here is a 20. They both have a total amount of 20, so let's see who put more juice in it. So Milton put 4 parts juice in there. Laredo put 5 parts juice in there. And so I would know that 5 parts juice would be stronger than 4. So Laredo is stronger than Milton, and Milton is stronger than Franca. And that's just using brainstorming, looking at the ratios themselves. But you also can actually use the value to make that same decision. Right below here, and I know it's kind of hard to see, and I'm sorry, so I'm going to read it out to you because I didn't give a lot of space for you to do the work. I calculated the value or the proportions for water to juice concentrate. The stronger the water, the weaker the taste. So over here, I have a 12:4 water to juice concentrate. When I simplified it, dividing them both by 4, I got a 3:1 water to juice. So 3 parts water to 1 part juice, or 3 times water than juice. For Franca, I had a 10:2, both with the greatest common factor of 2, which would give me 5/1, or 5 parts water for 1 part juice. That's 5 times as much water to the juice. So this is only 3 times the water, which means this would be stronger than this part because they're putting 5 parts water where this is only 3 parts water. And then we go to Milton, and Milton's value is 8/2, both being divided by 2 would be 4/1. So that's 4 parts of the water for 1 part juice, or 4 times as much water as juice. And so just looking at my numbers, 3 would mean the least amount of water, 5 is the greatest amount of water. So again, proving that Laredo would have the strongest tasting juice, and then Milton, and then Franca. And down here, that's all we had to write. Franca, Milton, and Laredo, because it wants to know the most water, and because they wanted me to put it in order for most water, that would be the 5 is the most, and then 4, which would be Milton, and then 3, which was Laredo. Down here, just explaining how to use value to solve that problem. And the way that we did that is I used the ratio of water to juice concentrate to determine the value for each person's juice. The greater their value, the more water is in the juice. And so, again, Franca, Milton, Laredo. Lastly, what is the ratio used to create each table? And the ratio is the water to juice. And then our water to juice ratios would be Laredo was 3:1, which again was our value simplified down. So you have to simplify all the way down as far as you can to get what your original ratio would be. Franca was 5:1, and the value was 5/1. And then for Milton, we found the value was 4/1, which would give you a 4:1 ratio. And the last part that I'll answer before you move on to your own piece of the exercises, they want to explain how the ratio could help you compare the juices. Again, each ratio shows how much water was added per 1 of the juice concentrate from the value we found. This allows us to compare the proportion of water to juice concentrate because it's comparing the same amount of the juice. So if you look above, I actually used the first thing I was explaining to you. I just was using ratios to make those comparisons. And so I had to make sure that it was the same amount of juice, which was 30 parts. But then I looked over here to see which part had more juice in it. And Milton had more juice because it was a 6, where Franco's was only a 5. And then again, looking at the same total that Milton and Laredo had, which was 20 and 20. And then I could say, okay, if they had 20 parts juice, who put more of the juice concentrate? And Laredo had more juice concentrate because it was 5 parts, where Milton only had 4 parts. Now what I would like you to do is go on and complete part B of the juice concentrate problem. I've given you an example with the same people on how to solve it, but if you look, the numbers are not exactly the same. And so what you need to do here is look for, this is apple juice, and it says from the order of the strongest apple taste, and the strongest apple taste means the greatest amount of the juice. Before we did the greatest amount of water to get the weakest flavor. They want to know which one would have the strongest amount of apple, which means which one put more apple to each proportion. When you're finished, make sure you let me know and I will check it.